Hey everybody, we're getting into chapter 2 today. So in this chapter we're going to be covering the chemistry of the human body. And I know a lot of people think, oh my gosh, I didn't want to take a chemistry class. This is not a chemistry class. It is anatomy and physiology. But without understanding the basics of chemistry, you're not going to be able to understand how reactions occur in the body, how homeostatic mechanisms occur in the body. So just knowing a little bit of chemistry is going to help you with understanding how medicines work at the cellular level or how foods affect your body. Okay, so it's important, especially if you're going into a medical field or any field dealing with the human body. So I always like to start it out with talking about the very broad terminology. So what is matter? Matter is anything that occupies space and has a weight. And so the table that you're sitting at, if you're sitting at a table, the bed that you might be laying on, the coffee cup that you're holding, I'm trying to show it over here, but it's really right here. See, my face is over in this corner, and so if I look over in that corner, it's because I'm trying to see what you are seeing on me. So, but I do try to look at you first. But this is all matter, and so this little tiny ferret-looking guy is doing chemical reactions and producing certain types of matter. And here's another matter. Matter can be found in multiple phases. One molecule that can be found in all three phases, most matter doesn't or is not seen in all three phases, but water is one that can be seen in all three phases. So it can be a solid, and in this case, if it's solid, it's ice. It can be liquid at room temperature. Water is liquid. And it can be a gas. So gaseous water is known as water vapor. What makes up matter then? Matter is composed of elements or atoms. An atom is the smallest unit that is considered to have a weight, okay? Atoms have specific numbers that are associated with them. So an atom with an atomic number of 6 is going to be different than an atom of an atomic number of 12. So you can identify your atoms just by looking at the atomic number. And the atomic number also designates the number of protons that are found in the atom. The mass of an atom then is going to be the number of protons plus neutrons, and it's the weight that that atom has. Protons and neutrons both contain a specific weight. You can see all of the elements in a periodic table. So here's a periodic table. I'm going to go to the page where this periodic table is found so that you can actually see it better. Boom. You can look at every single element. Don't worry, this is, again, not chemistry, so you don't have to memorize all of these different atoms. Even in chemistry, I didn't have to know all of my atoms, but I did have to know a few. So if you look up here, this is carbon. It has 6 protons, and so this is its atomic number. The mass then is down here, and it has 12.011 as its mass, which means it's slightly on average, it's about 12. It has a mass of about 12 atomic mass units. But there are different forms of carbon that might be more heavy and others that might be, but most are probably at the 12 range, okay? Okay, I already saw that. Don't want to see it again. There we go. So what are the most common elements that make us up? So if you look over here, this gives you the elements list of the most common elements that make us up, from most common to least common. I usually use CHNOPS, carbon, hydrogen, nitrogen, oxygen, potassium, phosphorus, and sulfur. Those are the most common items, but there's also very important sodium, chlorine, magnesium. These are electrolytes that we need in our system. Without these, we would be very, very, well, we would die. So we would be sick, but eventually if you didn't have them for long enough, you would actually die. So super important. Electrolytes are what help our muscles contract, help the nervous system function properly. And if you've ever heard of people saying you have an electrolyte imbalance, that's serious. You need to eat your bananas, drink your electrolyte fluids, whatever it is they're telling you to do. And assuming you're going to a doctor and not some weird quack on the street. Don't listen to everybody. This is a cute video that just talks about all the elements. I'm not going to watch it with you right now, but it's definitely a fun element song. I will watch one later with you, so don't worry. So what are atoms made up of? Atoms have 3 different structures associated with them. They have protons, which are positively charged. And so these red things here I've made as my protons, little positive charges inside. They have electrons in the outer orbitals that are negatively charged, and then they have neutrons, which have no charge. The number of protons and electrons are always going to equal each other in an atom unless they've entered into a chemical reaction. The number of neutrons varies. The number of protons is what dictates its atomic number and its actual chemical name. Whereas the electrons just equal the same protons and neutrons just vary depending. They just add mass. Electrons do not add mass, they're very small. So I made them smaller, but I wanted to make sure you could still see the negative charge and stuff. An isotope then is a variation within an atom. Isotopes are going to differ in the number of neutrons, so they will increase the atomic weight. And if you've ever, well, you just saw a periodic table, and I showed you carbon had an atomic weight average of 12.001. So in general, all of the carbon has 12 as its atomic weight, which means 6 protons, 6 neutrons. But there are different forms of carbon that will have 7 neutrons, and even some others that have 8 neutrons. But they still equal protons and electrons. So here's an example of an isotope. This is a typical hydrogen atom. A hydrogen atom contains 1 proton and 1 electron. That's it. But there are other types of hydrogen. This is the most common. Deuterium has 1 proton, 1 electron, and 1 hydrogen. So it has an atomic mass of 2. This is also known as heavy water, or hard water. Have you ever heard of that? And so I say that, and I know that you have. So that's what you're looking at. And then we have tritium. Tritium is the unstable form of hydrogen, which contains 2 neutrons. So you have your 1 proton, 2 neutrons, and it has an atomic mass of 3. This is also known as your radioactive hydrogen. So radioisotopes are the radioactive form of each atom. Every atom has at least 1 radioisotope. And these radioisotopes are going to continuously decay or break down until they become more stable. That's what they want to do. Because of this radioactivity, we have things like MRIs and X-rays and PET scans that we can use. Also, because of this, we can all be considered slightly radioactive because we are made of atoms. And so here are some I'm sorry. Nope.
The massage chair is working out for everyone.
What? Oh, no. Okay. Cancel. Okay. That is kind of cute. If you click on this, you'll get to a link or a video on Madame Curie. Madame Curie is the person who basically made or came up with the X-ray machine. So radioactive isotopes release radiation, and as they do, they become more stable. So in very high doses, radiation can be very deadly. Lower doses can potentially produce mutagenic or carcinogenic effects, but other forms of radiation can actually be used to help us. So we can use radiation to take pictures of our insides. So that's that PET scan, X-rays, MRIs. We can also use radiation to target tumors and cause those tumors to die because it does kill tissues. So here's an example of a PET scan. And a PET scan is basically a series of X-rays to produce an image using radiation. I'm going to stop here, and I'll start with our second lecture on the octet rule and atom binding. Okay? So have a wonderful day. Bye.